Hi guys, so today I'm going to show you something very special. It's very important in your calculus class, in your physics class, even in your maths, even just the maths, you also need this in the end. The Taylor series. So why this Taylor series is very important is because this Taylor series can actually approximate literally anything, any function. So before that, I'm just going to show you how to actually understand this even further. So consider this function f of x. I'm just going to consider this function f of x is equals to this part. This is the power series, by the way. So n equals to 0, and then you have a cn x minus a power n. I think that is the theorem. Yeah, sorry. Okay. So I will have to consider this. I think this is infinity. Okay, never mind. But in the end, you'll get it. So I'm just gonna consider this function. So I can say I can expand it even further. F of x is equals to, now I just do the subbing in now. Sorry, this is infinity. Yeah. Okay. So c of 0, which is the constant, plus c1, and then x minus a power 1, plus c2 x minus a power 2, plus c3 x minus a power 3. I'm just going to try to do until 5 lah. So plus c4 x minus a power 4, and then plus c5 x minus a power 5, and then dot 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 until cn x minus a power n. That is the power series, by the way. So this is the power series. So what I do next? Okay, now I'm going to try to differentiate the first equation. I'm going to differentiate this. So I'm just going to change to another pen. I will have f prime of x, which represents differentiation, which is equals to constant. When I differentiate, you will get 0. So I don't need to write this. C1, use the chain rule, you will realize that you will get 1c1, plus use the chain rule for this, you will get 2c2 x minus a power 1, and then c3, you will get 3c3 x minus a power 2, and then plus c4, and then you'll get 4c4 x minus a power 3, and then until lah, I'm just not gonna write power 5 lah, you will get like this, and cn x minus a power n minus 1. So what I'm doing now I will further differentiate it again. So I further differentiate it again. F prime of x, double prime, is equals to, this is a constant, remove. This one, I will write it as 2c2, plus this one, I will write it as 6c3, or 6 is equals to 3 to the factorial. So I'll write it as 3 to the factorial, c3, and then x minus a only, plus 4c4, which is 12, which I can rewrite it as, 4c4, 12 is 3 times 2. Oh, cannot. Okay, never mind. Just leave it. So 4c4, you will get 12 c4, and then x minus a power 2. So you will, in the end, you will get n minus 1 bracket cn x minus a n minus 2. Now what I do, let's differentiate it again, the third time and the last time. So I differentiate again, this is a constant, remove. So now this one, it becomes 3 factorial C3, and then this one you will get 24, which is 4 to the factorial. So C4 x minus a, and then it keeps going, n minus 1, n minus 2, Cn x minus a, n minus 3. Realize that this part, right, is actually also n to the factorial. Okay, now what I do? Now, right, I'm going to sub x equals to a. So prime, triple prime is a. So you will realize that, right, this whole part, right, if I sub it a, is actually equals to 0 only. This whole thing equals to 0. So this whole thing equals to 0. So I'm actually left with C3. Okay, so if I want to find the value of the constant C3, I will just have to take f the triple prime of a divided by 3 to the factorial. So this is how the Taylor series work. So the Taylor series actually tells me that yes, this is n equals to 0. I'm so sorry. N equals to 0. F power n. This means that I differentiate how many times in my expression. So just now I differentiate 3 times only. So now I represent it power n. Bracket a divided by n to the factorial, because you see just now here is 3, here is also 3. And then bracket x minus a power n. This is the Taylor series formula. Okay, now right, I'll just show how a question. I'm just gonna take a sample question. Alright, let's look at this question. So it says find the Taylor series for fx is equals to 7x squared minus 6x plus 1 about x equals to 2. So what I do first, I'm just gonna write fx equals to 7x squared minus 6x plus 1. Usually when it comes to these questions, right, the Taylor series, I would differentiate it until there's no more differentiation. Or sometimes when it's an infinite differentiation, I'll differentiate it 4 times the maximum. The minimum 4 times. Now you can do more, but I will differentiate it 4 times. So now I do f prime of x is equals to this one, you put it down, 14x minus 6. That's the first part. If I differentiate it again, f double prime, you will get 14. So if I differentiate it the third time, which I'm gonna write in this symbol, you'll get 0. So that means it's actually a constant already, the 14, and then when I differentiate it the third time, in the end you'll get 0. Okay, so let's write it down, the formula. So how do I actually calculate? You can calculate like this. Okay, so what it means, right? So that means x equals to 2, right? Now my value x minus a, this power n, so this I can represent as 2. So how I'm going to write, hold on a sec. Okay, 7x squared minus 6x plus 1 is equals to infinite expansion. Actually, you don't really need the Taylor's expansion. You can just use binomial for this, but I will just show you Taylor's expansion now. So this is n equals to 0, and then f, because it asks for 2, I give here, and then this one will represent 2, and then for n to the factorial, about x minus 2 squared. Okay, so from here, hold on a sec. Okay, so from here, right, what you have to do, right, you just sub in the value. So you just sub in the value, so you have like f2 plus f prime 2, wow, a lot but yeah, this is how it works. So plus 1 over 2 f dash 2 and then something like that lah. So I just stop until here. So 1 over 2 2 sorry f prime prime 2 s minus 2. Okay, yeah. Is it 2s minus 2 squared? Sorry. So from here you simplify. I think from here then you will get, so so 28 minus 12 plus 1, 16 plus 1, 17. F prime is 14. Just sub in the value lor. So you just sub in the value, you will get 14. So 14, 28 minus 6 plus 22 x minus 2 plus, here is 14, right? You just sub in. So you just sub in this part, you will get f prime prime 2. I think you will get 7. F prime prime 2 is 7. X minus 2 squared. This is your final answer. So this is how you do Taylor's expansion. It's quite hard, but yeah, try to work on with the tutorial with this. Thank you.